In this video, I will demonstrate how to use the Qualitative Exposure Assessment tool, or as it is better known, the checklist. Be sure to enable macros in the Excel before opening the checklist. When you open the checklist tool, you'll see this page. For exposures involving volatile or semi-volatile chemicals, you'll click on the red arrow. For exposures involving particulates, fibers, and aerosols, you will click on the black arrow. When using the tool for the first time, and to learn more about how the tool works, click on the gray arrow. As I click on the red arrow, I'm taken to the page you see here. The column on the left is used to identify the chemical of interest. Notice the red box at the top that says gas and vapors, and serves as a reminder that these two heuristics relate to vapor and gases. Each column represents a discrete heuristic, meaning that there are two ways to estimate the exposure category for gas and vapors. Notice the numbered circles, providing you with a checklist that tells you in which order to complete each step. And in fact, the checklist tool will perform some of these steps for you. So, to start, select the chemical of interest. In this example, I'm selecting isopropyl alcohol. Notice that when I did this, the tool populated several other cells, including the occupational exposure limit, or OEL, vapor pressure, and saturated vapor concentration fields. If you select a chemical not yet in the database, you will also need to supply the occupational exposure limit and vapor pressure. Okay, having selected the chemical, I'll start with the rule of 10 heuristic located in the central column. As you would with any checklist, we proceed by following the numbered steps. For number 1, I want to confirm that the OEL I want to use is the one shown here. If not, I simply change it. For this demonstration, I'll leave it at 400 parts per million. Number 2 asks for the vapor pressure of the pure chemical at the temperature that coincides with the exposure scenario we're assessing. In our case, it's room temperature, or 25 degrees C, so the value of 45.4 millimeters of mercury is correct. Number 3 requires our assessment of the type of workplace controls present. So in this case, I happen to know that there's good ventilation in my workplace, delivering about 6 air changes per hour. So I select from the drop-down menu, Good General. For the Rule of 10 heuristic, the tool completes the remaining steps in the checklist for us. The tool calculated the saturated vapor concentration based on the vapor pressure of isopropyl alcohol. It also calculated the expected reduction in the airborne concentration based on the type of control I indicated. It then calculated the fraction of the OEL that this reduced concentration represents, and it compared this fraction to the AIHA exposure control category criteria to predict a Category 2 exposure. Now let's move on to the second vapor and gas heuristic, the vapor hazard ratio, shown in the column furthest to the right. Notice the tool has already identified the required level of control. That is, the level of control deemed necessary to adequately control this chemical. This information was taken from the vapor hazard ratio table, which you can learn more about in my introductory video, or in Chapter 26 of the AIHA Exposure Assessment Strategy book, 4th edition, or in our paper published in the Journal of Occupational and Environmental Hygiene. I want to emphasize the importance of understanding the criteria and how they are applied. Since the last step we completed in the checklist was number 7, for the rule of 10, the next one to complete is number 8. Once again, I need to indicate the level of workplace control present. And note here that the criteria are slightly different to the criteria used for the rule of 10. So I'm going to select Good General Ventilation, indicating 6 or more air changes per hour. As you can see, once I provided this information, the tool completes the checklist and predicts a Category 2 exposure. Happily, in this case, both the rule of 10 and the vapor hazard ratio heuristics are in agreement. This isn't always the case, and in such situations, I recommend using the more health conservative category as a preliminary assessment. Now, to demonstrate the heuristic related to particulates, fibers, and aerosols, I'm going to click on the Home button and then on the black arrow. There is only one heuristic here, and using it is pretty simple. To start, I look up the OEL for the chemical of interest and then select the range in which the OEL fits, as indicated in step number 1. For this example, let's use the ACGIH TLV for respirable silica, which is 0.025 milligrams per cubic meter. And so you can see from the drop-down menu that I've selected the correct category. The particulate hazard ratio, similar to the vapor hazard ratio, has deemed the required level of control for chemicals with OELs in this range to be containment. For step number 2, I indicate the level of workplace control present. Let's say for this example that it is good general ventilation with 6 or more air changes per hour. As you can see, the tool predicts a Category 4 exposure based on the information I have provided. So that is how to use the checklist tool. Best practice dictates that it should be calibrated to your workplace and work scenarios, using scenarios for which robust quantitative exposure measurements have been collected, so you're confident that you know what the true exposure categories are. Finally, your feedback and suggestions on the tool are always welcome. You can send those to me, Susan Arnold, at the University of Minnesota.